Hi, it's Ms. Richmond. I want to tell you a little bit about functions today. So for this particular topic, we have a fair amount of vocabulary. The good news is it basically comes in groups. So the first group, and these are all pretty close to synonyms, so they mean very close to the same thing. The first group is input, x's, independent variable, and domain. So these are all in one group. The second group, you can see how these correspond to the first group. Okay, but the second group is the output. So if you have an input, there's an output. For the x's, there are y's. For independent variables, there are dependent variables. And for elements or parts of the domain, there are elements of the range. And then the two concepts that tie the groups together are relation and function. So we'll get to what those mean a little bit later on. For right now, let's concentrate on group 1 and 2. So actually, I think you've probably seen before, maybe from elementary school, something called a function machine. And sometimes it's represented kind of like a rectangle, or sometimes there's little legs or something on it, but it's a machine, and there's usually an input. So something comes in, and then there's an output. Something comes out. Okay? So for example, if your machine has a certain rule, maybe your rule is 2x plus 1, then if you have as an input or your x variable, let's say you have 3, then what would your output be? Well, your output would be 2 times 3, that's 6, plus 1 is 7. So your input is 3. So this is your input. It's also an element of the domain, and we write our domain as a set. So 3 is one element in that set. Okay, it is also your x variable, and it's called the independent variable. It's the thing you start with. It's independent. So independent variable. And this here, your 7, is what came out of your machine. It is your output. Or if we write this as y equals, then it is the y value. It is an element of the range. And just like the domain is a set, the range is a set. The first element is 7. And 7 is our dependent variable. The value of 7 depends, it's dependent variable. Okay, it depends on the value we put in, the 3. So let's try another one. Let's say we put in 0 for x, then 0 is an element of our domain. And what would come out? 2 times 0 is 0, plus 1, a 1 would come out. So 1 would be an element of our range. Okay, so in this particular example, we have 2 elements of our domain, 3 and 0, and we have 2 elements of our range, 7 and 1. Just as a note for you, in science, if you have time as one of the variables, time is almost always your input. It's the independent variable, or the x. Okay, so now we've talked about group one, input, domain, x values, and independent variables. They're all very similar, and the same with the group two, output, y, range, and dependent variables. Okay, so let's move on. So here's an example. The cafeteria sells cookies for $1.50 each. What is the domain? So that means what values of x could we have? In this case, cookies are the independent variable. So what values could we buy of cookies? Well, we could buy, I'm going to list elements of our domain. We could buy 1 cookie, or 2 cookies, or 3 cookies, or 4 cookies, etc. All right, now the cafeteria is not going to sell us 1/4 of a cookie. So we can only have as our domain, we can only have positive integers. Okay, we cannot have negatives. They're not going to sell us negative cookies. We can't have fractions or decimals. What's the range? Well, if I buy 1 cookie, I would pay $1.50. If I buy 2 cookies, I'd pay $3. If I buy 4, I'd pay $4.50. Sorry, for 3 I'd pay $4.50. For 4 I'd pay $6, etc. Okay, so if we think about what these are, 150, 3, 450, 6, these are going to all be multiples of $1.50. That's our range. It's the elements that we could have as our y values. Okay? So this brings up our next vocabulary word, relation. A relation is a mapping or a pairing of elements of the domain with elements of the range. So for 1 cookie, I'd have $1.50 is what I'd pay. For 2, it would be $3. For 3, it would be $4.50. We can see that I've got a mapping here of elements of the domain and elements of the range, a pairing of them. So this is a relation. Okay, if we go on, I'm going to give you another relation. Here's x, here's y. And let's just put in any numbers for x, maybe -4, 6, 9, 14. And let's pick numbers for y. They can be any ones we want. 5, 0, that should be a 6. 10, maybe -8. All right, this is a relation because my x's are paired with y's. All right, so this is a relation. Now, my domain in this relation is the set of values x can be. So there are 4 of them. I literally just list them off. -4, 6, 9, 14. That's the domain. The range is the set of values that y can be. So I list those off. 5, 0, 10, and -8. Those are my values of my range. Again, just list them from the chart. All right, so this is a relation. It's actually a very special kind of relation. It's called a function. And that's our last vocabulary word. A function is a relation in which for every element of the domain, or x, there is exactly one element of the y. So notice that for every x over here, there's exactly one y. So this is a function. Now, let's look at this one. X, y. When x is 2, I'm just making up some numbers. Let's first of all give myself some values for x. 2, 5, 8, I don't know, -3. And now I'll pick some values for y. I'm just picking these randomly. I'm not using any rule at all. I'm just picking random numbers. So maybe 9, -1. You know what? I like the number 9. I'm going to use that again. And I'm going to use 4 here. And I'm also going to use another 2. And I'll put a 0 with it. All right, so now if I try and match these up, well, here 2 goes with 0. But 2 also goes with 9. So for this value of x, for the value 2, which is in the domain, 2 has more than one output. Okay, so this is not a function. It doesn't matter that there are 2 9s here. This is what makes it not a function. The fact that if I put in a 2, I don't know if a 0 would come out or a 9. If you think about a function, let's say you're making something in a factory, like shirts. If you're making a shirt, you want to know that if you put something into your machine, you want to know exactly what's coming out. You don't want it to be a mystery. But here, if I put in a 2, I don't know what's coming out. It could be a 0, it could be a 9. That's a bad machine. This is not a function. Okay, let's try another one. Let's see if I go here. In this relation, 2 inputs have the same output. So here's x, here's y. So 5, maybe it goes to 3. 7 also goes to 3. 8 goes to 11. 9, maybe it goes to -6. Again, I don't have a rule. All right. So I have 2 inputs that have the same output. So if I put in a 5, I get a 3. If I put in a 7, I get a 3. 8, of course, is 11, and 9 is -6. But I have 2 inputs with the same output. Is it a function? Well, think about if you're in a factory. Here's your machine, okay? And you put in a 5. Do you know exactly what's coming out? Yes, you do. You know a 3 is coming out. If you put in a 7, do you know what's coming out? Yes, you do. You know a 3 is coming out. Now, this is a function.